In this question it is given that the thickness of ice in a lake is 10 centimeter and it is temperature is minus 10 degrees Celsius. Thermal conductivity of ice is given 0.04 calorie per centimeter per second, and the density of ice is given 0.92 gram per centimeter cube. Latent heat of ice is given as 80 calorie per gram. The time taken for thickness of ice to be doubled is. So the equation for time taken to form x thickness of ice is T is equal to, you can use this equation, x square into rho is density into latent heat of fusion, divided by 2 into K into T, where K is nothing but the conductivity of material where it is ice, and T is representing the difference in temperature. So we can write according to this equation. Initially thickness was something like let's say x1, which is equal to nothing but 10 centimeter, and after that the thickness becomes equal to x2, that means its thickness is doubled, so we can write it is going to be nothing but 20 centimeter. So Rm is to find out the value of time taken to double its thickness. So we can write the from 0 to x2 the time taken is, we can write T2 is equal to x2 square into rho into latent heat of fusion divided by 2 into K into T, and the value of T1 is equal to, we can write it as x1 square into rho into latent heat of fusion divided by 2 into K into T. So from 0 to x1 time T1 and 0 to T2 0 to x2 time is T2. So Rm is to find out the value of T1 to T2, or the time taken to change the thickness from x1 to x2. So we can write which is equal to T2 minus T1. So we can write this as equal to x2 square minus x1 square into rho into latent heat of fusion divided by 2 into K into T. Now the value of x2 is something but 20 centimeter, so we can write this as 20 centimeter square, 400 minus x1, which we can take it as 10 centimeter square, which is 100, into density of ice. In this question it is given that 0.92 into latent heat of fusion, which is nothing but 80 calorie per gram divided by 2 into the value of K is given as thermal conductivity, which is given in question as nothing but 0.004 calorie per centimeter per second. So over here I'm not converting the unit because this is given in calorie, and this latent heat of fusion is also taken in calorie. So this even if you are changing unit, these are going to get cancelled, the conversion factors are going to get cancelled, so that's why I'm just taking it in calorie only. Into temperature, the value of temperature over here, it is given that temperature is temperature difference, which is minus 10, and outside temperature we can assume that it is equal to 0. So the temperature difference we can take it as that is equal to 10. So this is equal to 400 minus 100, which we can take it as 300 into 0.92 into 80 divided by 2 into 1020 into 0.004, which is equal to, so we'll get the answer as 276000, or you can write 2.76 into 10 raised to 5 second.